what is y prime?
No,
MV to the MS.
And then y double prime?
M squared e
Right.
to the MS.
Now remember, in order for this to be a solution, the left and right-hand side have to be identical. Okay, so the left-hand side will have to be equal to 0 for every single x, right? So this would be m squared e to the mx minus 5m e to the mx plus 6e to the mx. Any ideas from here?
I took e to the mx out,
Yes.
and then, yes, I guess we'll, or maybe after that, sorry, we'll,
Factor?
yeah, sorry, that's right.
Yeah, it sounds like you,
But
just
that-
about there.
Yeah,
So this will be true if one or the other is equal to 0, right?
yes,
This times this equals 0 means that either e to the mx equals 0, or this equals 0. What can you say about this equation?
no, neither because
No, yeah, exponentials are always positive, so there are no solutions here, neither for n nor for x. Okay, so this is independent of x, which is a good thing, right? Because this should be equal to 0 regardless of the value of x. So if you factor, we have m minus 2, m minus 3 equals 0, so that tells us that n is either equal to 2 or 3. Okay, so what would that mean? That would mean that, so if m is equal to 2, y equals e to the 2x, and if m is equal to 3, y equals e to the 3x. These are both solutions. Does that make sense?
yeah.
Yeah, so now that you know what the solutions are, you can try substituting and see that it all works out. 23?
Yes, but I think this might answer.
What was the assumption that you made? Now, you also have the instructions. I'm going to disregard this interval of definition. Okay, so any of the instructions that involve the interval of definition, you can ignore that. This one has that
yeah.
in the instructions.
No,
So it says, verify that the family function is a solution of the given differential equation. We will do that. Assume an appropriate interval I definition for each solution. You can ignore that.
What was the number?
So what was the assumption that you made?
I was working it out, and I made the assumption that it was equal to 0 because all the the numerical coefficients canceled out, and then I think that's obviously wrong. Because of
Well,
this.
C1 and C2 you should understand to be constants.
Right.
So,
Because I think one C2 remained. I was like, oh, I don't know. That
well, let me just work it out from scratch.
Okay.
So the equation is, I'll use prime notation. This is the equation, and then suppose that the solution is this. Okay, so we need to check that this actually is a solution, right? So again, to check that it's a solution, we need to substitute for y in each of its derivatives. Then the first and second, right? What's the first derivative?
was what I got.
2c1
Right.
e to
C1,
x
e to
to
2x.
x plus c2 e to the 2x.
Careful here to differentiate, you need to use the product.
Product rule, so yeah.
Okay, so if you differentiate x, you get C2 e to 2x plus, and then if you differentiate e
Isn't that
to
what I said?
2x, 2 C2 x e 2x.
That's what I said.
Right?
I think that one part of it out. Yeah, that's right.
And then you also
You
need
left something
the
out.
second derivative. so derivative of this is 4c1 e to the 2x.
2C2 e to the 2x.
2x.
4C2.
Well, it depends. Again, we need to use the product rule, right? So if you differentiate the exponentially, you'll get 4c2x e to the 2x. And then
2C2.
yeah, then differentiate x. 2c2 e to the 2x. Okay, so it's gonna be kind of a mess. So I need to, let's see if there's anything. So
Got the 2.
these will make 4, right?
Then you can take out the 4e to the 2n. Take out 4 as a constant and then like.
We probably don't want to factor because everything should add up to 0. So,
So the other thing I did was I added 2C1
for
e
y
to x.
prime, it's 4c1 e to 2x. Okay, this all is y prime and then minus 4 times, sorry, y double prime. That's 4 times y prime. Okay, so this is all y prime and then plus 4. 4 times y, this is y. Okay, so if this is to be a solution, everything should add up to 0, so everything should cancel completely. I don't really feel like writing all of this. Can we just visually check the terms? We've got 3 different types of terms. We've got e to the 2x, c1 e to the 2x, c2 e to the 2x, and c2x e to the 2x. These are the 3 types of terms that we have. Agree? Okay, so let's check the c1 e to the 2x terms. So here I have 4 of them, right? Minus 8 plus 4, those terms cancel. Right? Let's check the c2 e to the 2x. Here I have 4 minus 4, right? Here there are none, so those cancel. And then 4c2 e x e to the 2x minus 8 plus 4. Okay, so 0 equals 0. Check. Yes.
The other thing, I guess it came out the same, but I don't know if it's something we can do. So I combined the C1 and the C2s. Like I made it 4C1 C2 to e to the 2x.
Well, it wouldn't be 4c1 c2.
No. Okay.
It would be 4c1 plus 4c2 times e to the 2x.
Right.
Okay.
That's what I meant.
You could do that, I guess.
I just wondered. That's what it cancels out the same. That's why I was.
Yeah, with these, it's probably better to leave them as individual
But yeah, I think
terms
it
than
left
try
with
to-
one C2 that got misplaced by doing that. So I think
Yeah,
that's why.
this one's such a mess, you should probably check your work
So
and you
just
might have overlooked.
Leave it like that and don't try to.
Yeah, I
combine
mean, so I'm going to give you guys a quiz on Tuesday. So, I'll give you something like this, a quiz. Don't just, like, do this, okay? Show me some sort of demonstration that things are fixing, okay? So, I guess I should, let me finish it up to show you what I would like. Instead of checking it like that and crossing things out, there are 3 different types of terms, right? So show me the coefficients. So do what I did. Got 4 minus 8 plus 4. Okay, so 4 minus 8 plus 4. this way I can see why it's canceling, rather than just putting lines through it, because it's supposed to cancel. Okay? Anything else? Yes?
I guess you don't have to go through the whole thing. I mean, I feel like it might be long, but I didn't really know how to approach number 25. Like with the,
You know,
unless.
I used to have an example like that in the notes, and then I removed it from the notes. So there's something a little bit technical here, and that's why I removed it from the notes. Let me just tell you, so that I don't overlook it entirely. There's a discussion about the difference between y as a function and y as a solution to a differential equation. Okay, so in order to be a solution to a differential equation, not only does it have to satisfy the equation, but the expression has to be differentiable. Is that obvious? Like if I even intend to substitute it into the differential equation, then I have to be able to differentiate it. So that means something like y equals absolute value of x. Could that be a solution to a differential equation?
No,
Why not?
because you can't differentiate that.
You can't differentiate it
Right.
at 0, right? So, because it comes to a sharp point, right? So it's not differentiable there. So, you know, sometimes people refer to differentiable functions as smooth functions. Have you heard that before? If it comes to corners, then it's not differentiable. You know, if it's not continuous, it certainly is not differentiable. So if you have a continuous function that's not differentiable, it comes to a corner. Okay, so, so let me work this out, and then this will be the last that I say about what it, the idea of integral definition. So this is a piecewise defined function. Y equals minus x squared,
Check.
x is less than 0, and it equals x squared if x is greater than or equal to 0. Okay, so we're asked to check if it's a solution to okay, so there are 3 things that we need to check. And those 3 things are.
It's continuous.
That's part of it, yes. But not just continuous, but differential. Right. Where might you be concerned if this is differential? At 0, right? If it's less than 0, this function is differentiable, right? If it's greater than 0, this function is differentiable. Exactly at 0, it may or may not be differentiable. So first of all, you might have a jump discontinuity. Secondly, you might have a point. You know how to check whether a piecewise function is differentiable at the place where you change pieces.
At some time I
Apply
did.
it and see if it's the same.
Apply what?
Apply the point where it's changed over and see if you have the same, same number.
Same. So if I substitute 0, both of these are 0,
Yes.
what does that tell us? Continuous. How would you check if it's differentiable? This is way back from Calc 1.
Find the limit as opposed to 0.
Yeah, the limit of the difference quotient. So you need to check the left-hand derivative and the right-hand derivative. Does that make sense? So not only does it have to meet at the same point, but the slopes have to agree. If they do, it'll be smooth. If they don't, you'll come to a point. Okay? So first of all, to check if it's differentiable, y prime, so if y equals minus x squared, y prime is equal to minus 2x, y prime of 0 is 0. Okay, so the left-hand derivative is 0. Let's check from the right. So if y is equal to x squared, y prime equals 2x, y prime of 0 is equal to 0. Okay, so this is differentiable. If you can imagine, this graph looks something like this. It's a upward sloping parabola on this side and downward on this side. So you can see that it has a horizontal asymptote right here. Okay? Or horizontal tangent line. So this means that it could possibly be a solution because it's differentiable everywhere. So that's the one thing that you need to check. What do you suppose the other two things are that we need to check? We already checked that it's continuous. I mean, ordinarily, what do we do to check to see if the function is a solution? We substitute it, right? But here we have two different functions, right? So we need to check if the left-hand piece is a solution, and we also need to check if the right-hand piece is a solution. Okay, so if y is, or sorry, x is less than 0, then we know that y is equal to minus x squared, right? So let's substitute this into the equation, first derivative. Okay, so if we substitute, we get x minus 2x plus minus x squared is equal to 0. So this is minus 2x squared plus, sorry, right? Plus 2x squared equals 0. Okay, so the left-hand piece is a solution. And then the only thing that's going to change if I substitute the right-hand side is this will be positive, this will be negative. Okay, so if x is greater than 0, then y equals x squared. Okay, so x times 2x minus 2 times x squared equals 0. Check. Okay, so the left-hand piece is a solution, right-hand piece is a solution, and if the place where it changes, it's differentiable. So altogether, it's a solution. Make sense?
What is that?
What is
The
what?
second one. It says x in parentheses minus 2x plus.
Here.
What? How do you do that?
Minus 2 minus x squared, this.
You know what I'm saying? Where did that equation come from?
Oh, I'm substituting the function and its derivative into this equation.
Oh,
So x times minus 2x is the derivative, minus 2 times x squared.
Right.
Okay. Other questions? Okay, so about the quiz, remember that if you complete your homework assignment, the quiz problems will come from the homework assignment. They'll be numbered, so all that it will take is for you to copy your answers of them. Okay. So please finish the homework assignments for 1.1 and 1.2. So section 1.2 is mostly definitional. Again, we'll get into some more information